Right, and conditions for a parallel line and perpendicular lines. Right, conditions for parallel lines and perpendicular lines. So these two terms are terms worth knowing in geometry. So lines can be parallel, perpendicular, or any other thing. So when it's my rule, perfect line, right? So when we draw lines, and then they meet at an angle 90 degrees, then we say they are perpendicular. When we draw lines and the angle between them is 0 degrees, then we say they are parallel. So for instance, these lines, uh, so assuming they are parallel, it means they will go and then they will never meet. When you extend these lines, they are not perfect because I drew them with my hands. But for perfect parallel lines, they will never meet. So the angle between this line and this line is 0. There is no angle between them. However, when we have perpendicular lines, like a line like this and another like this, and then they meet and then form an angle here, which this angle is 90 degrees, we say these lines are perpendicular. Perpendicular. And then these are parallel. So parallel lines and perpendicular lines. So as we learn about lines, we have to learn a little in relation to they being parallel and they being perpendicular. So let's see. Let's start with parallel lines. If two lines L1 and L2 are parallel, they are equally inclined to the positive direction of the x-axis, corresponding angles. Therefore, tan theta of the gradient of points of both L1 and L2 is the gradient of both L1 and A2. Hence, the two lines are said to parallel if they have equal gradient. Sorry for reading it badly, but I think you can refer yourself. So the two lines are said to be parallel if they have equal gradients. So let me explain this. If I draw the Cartesian plane and I draw this line and I draw another line, right, and I draw another line, this line, because these lines are parallel, if I want to measure the angle they make with the positive x-axis, like for instance, if I bring the positive x-axis here, this angle here, then if I bring the positive x-axis here, this angle here, they all make an angle with the positive x-axis, and these angles will be equal since they all are parallel. When two lines are parallel, they make the same angle with the positive x-axis. So if these lines are said to be parallel, then if I draw this one and if I draw this one, the angle here and then the angle here will be the same. So that's what they are saying there. And then we know the formula for gradient is tan theta, right? That's one of the formulas, tan theta. If theta is going to be same for both lines L1 and L2, these are the two lines L1 and L2, then it means that both L1 and L2 will have the same gradient. So that is true. That is the point they make here. That if lines are parallel, then they have equal gradients. So we need to keep that in mind. So I'll use the red ink there. If lines are parallel, they should have the same gradients. Perfect. Let's go back to my yellow marker. Yellow. Now that's it for parallel. What of perpendicular? If the gradient of one line is equal to the negative reciprocal of the other, then the two lines are said to meet at right angles and are perpendicular. So that's the key. If the gradient of one is equal to the negative reciprocal of the other, if the gradient of one is equal to the negative reciprocal of the other, that means that if we have lines L1, let's see, yes, this line L1 and this line L2, if these lines have gradient, if that the gradient of line 1 is m then the gradient of m2, right? The 1, right? The gradient will have this relation. 1 will be the negative reciprocal of the other. That means 1 is 1 over m1. That will be m2. So if L1 has gradient 2, then L2 will have gradient negative 1 over 2. If L1 has gradient 4, then L2 will have gradient negative 1 over 4. If L1 has gradient half, then L2 will have gradient negative 2, because that's negative 1 over half. That will give you negative 2. If L1 has gradient negative 1 over 6, then L2 will have gradient negative 6, positive 6. So that's it for perpendicular lines. So the relation for perpendicular lines is when you multiply them, because they are negative reciprocal of each other, when you multiply them, you're supposed to get negative 1. That means always m1 times m2 will be equal to minus 1. So that's here. You should memorize that, or you could memorize this. This is the same thing. So don't memorize this one, because if you multiply m1 and m2, you get negative 1 here, right? So they just made m1 the subject in this one, right? And then they get. So it's better I memorize it. It's simple. So memorize this. And these are the two things you have to memorize about lines being perpendicular and parallel. Okay. So let's try solving some examples. In example 1. In example 1. Wait, it can't be fully there. This is all part of the mark experience, so why don't you come? Perfect. In example 1, find the equation of the line which passes through the points 1, 3 and perpendicular to the line 2y minus 3x plus 1 is equal to 0. So we've been asked to find the equation of a line. So we are finding equation. We are finding the equation of a line. We've learned how to find the equation of a line. We learned some cases. We learned a case where we'll be given 2 points. We learned another case where we'll be given a gradient and a point. Right? In this case, we've been given a point. So let's say this point is P. So 1, 3. Were we given the gradient? No. But we're given a clue to find the gradient, right? The question says that this line that we are finding the equation of is perpendicular to this line. This is another line. Whenever lines are perpendicular, the product of their gradient is equal to negative 1. That means that if the equation of this line is m1, the gradient of this line is m1, then the gradient of this line is m2. m1 and m2 give us negative 1. So let's find m2. Let's find the gradient of this line. We have 2y minus 3x plus 1 is equal to 0. Let's find the gradient of this line. We know how to find the gradient of a line. You just express it in the form y is equal to mx plus c, right? And then you find the gradient. So let's express it in the form y is equal to mx plus c. Y is equal to minus 1 and 3x minus 1 over 2. So y is equal to 3 over 2x minus 1 over 2. So this is the equation of the line, this line, right? And then expressed in the form y is equal to mx plus c. So when we compare y is y, m is 3 over 2. So the gradient of this line, which is m2, is 3 over 2. Now m1, we don't know m1. How are we going to find m1? With this equation. The equation we learned from this part, m1 and m2. The key word there is perpendicular. When they are perpendicular, their product is negative 1. So I need to find m1. I'll make m1 the subject in that equation. m1 will be equal to negative 1 over m2. So if I find negative 1 over m2, which is 3 over 2, I'll get 3 over 2, then negative 2 over 3. So this is the equation of the line I'm supposed to find. This is the gradient, sorry. This is the gradient of the line I'm finding. Now I have the gradient, I have a point. With these two, I should be able to find the equation of every line. So I'll state my formula: y minus y1 is equal to m into bracket. So in this case it become m1 x minus x1, right? Because I'm using this one, this number, this gradient here. So substituting, we have y minus y1 is from here 3, m1 is minus 2 over 3, x is 1, then x is x, and then and then x1 is 1. I multiply through by 3 to get rid of the fraction because I don't want fractions in my equation. I want it to be simple. So 3y minus 9 is equal to minus 2x minus 1. I also don't want parentheses in my equation, so I'll expand the bracket. That will give me 2x minus plus 2, 2x plus 2. And then I don't want terms of the same side on different sides, so I'll put all the terms together so that I'll have a simple equation. So in there I'll bring this 2x here, and I'll put 3y here, and then I'll bring this 2 here, so minus 11 is equal to 0. So this is the equation of the line. It's the equation of the line, right? So this line is perpendicular to this line. So in the end, that's what I have here. In question 2, find the equation of a straight line which passes through the midpoint of the line joining the points this and this, and perpendicular to the line this. So the key words here are midpoint and perpendicular. From perpendicular to this line, we can get a gradient because we've been given a line and then we've been told that find the equation of another line which is perpendicular to this line here. That means that whatever the gradient of this line is, the negative reciprocal will be the gradient of my line. So let me find the gradient of this line, m1, right? Let's make m1, right? So gradient of this line is m1. So m1 will be 3x minus 2y minus 5 is equal to 0. Minus 5 is equal to 0. I will express it in the form y is equal to mx plus c. So expressing this in the form y is equal to mx plus c, I have y is equal to 3x minus 5 over 2. That's y is equal to 3 over 2x minus 5 over 2. So that is my equation. That means that m1, therefore m1 is equal to 3 over 2. The equation of this line is 3 over 2. This line of this line is 3 over 2. Now what is the equation of my line? Right? The equation of the straight line we are finding. What is the equation of that line? Right, so I think we made a mistake here. It's plus 3 plus 2y instead. So let's change this to plus, and then that means we change this to minus. That means we change y to a minus. That means the gradient will be minus 3 over 2. Right. So the gradient is minus 3 over 2. The gradient of m1 of the line we've been given is minus 3 over 2. That means therefore the gradient of our line, which is m2, is equal to 2 over 3. If you don't know how I did it, I used m1, m2 is equal to minus 1. I make m2 the subject, and then I substituted this. In the end, you get this. So therefore, the equation of my line, right, the line I'm about to find is 2 over 3, and that's what I'll use. Now, I need more than just the gradient to find the equation of a line, right? I need to have at least one point on the line. That is where this point, this keyword can be used. You said a point, right? This is supposed to give us a clue to a point on that line, right? It passes through, right? This equation passes through. It means this point is on the line. If a line passes through a point, means that point is on the line, right? So yes, it's like when a road passes through a town, then it means that town is on that road. We can say that town is on the root. So the same way, these two passes through the midpoint of the line joining this and this. We know how to find the midpoint. That means that the point is not passing through this, neither is it passing through this, but it's passing through the midpoint. So we need to find the midpoint. So midpoint, we know how to find midpoint. It's given by x1 plus x2 over 2, y1 plus y2 over 2. So midpoint becomes x1 plus x2, that is 1 plus 2 over 2, and then y1 plus y2, that is 2 minus 3 over 2. That is 3 over 2 and minus 1 over 2. So these are the midpoints. This is the midpoint. This is the point where we'll use. This is the point we can use to find the equation of the line. So this is the point we can use to find the equation of our line. Let's see. Now we have our gradient, which is 2 over 3, and we have our point, which is 3 over 2 and minus 1 over 2. So now we're supposed to find the equation y minus y1 is equal to m to bracket x minus x1. Let's substitute y minus y1 here is half, so that's plus half because minus minus is equal to m is 2 over 3, and then we have x minus 3, minus 2 over 3, 2 over 3, 2 over 3, minus 2 over 3. Right, there are lots of fractions in there. I want to get rid of the fractions. I multiply 3 by 6 because the denominators I have 2 and 3. LCM is 6, so I multiply 3 by 6. If I multiply 3 by 6, I have 6y plus half times 6 is 3. This times 6 is 4, right? Because this cancels 6, 2 times 2 is 4. Then I have x plus 2 over 3. I will, try and simplify it further. 6y plus 3 is equal to 4x plus 8 over 3. Let's multiply 3 by 3 to get rid of this fraction. So I'll get 18y plus 9 is equal to 12x plus 8. 12x plus 8. So we have 12x minus 18y minus 1 is equal to 0. Because I maintain this, and then send t to our slip outside. So the equation of the line here is 12x minus 18y minus 1 is equal to 0. And that is it. 12x minus 18y minus 1 is equal to 0. Where's the answer? Whoa. We are wrong. We are wrong. Let's see. So this is where we missed it. This is where we missed it. We, instead of 3 over 2 for x, we did the 2 over 3. So x here is 3 over 2. It's not 2 over 3. So we'll have to change that to 3 over 2. And that will change here to, and I think that will change everything here too. So let's clean all this. That's 3 over 2. And then we simplified further, so 6y plus 3 is equal to 4x plus 12 over 2. That is 6, right? So 6y plus 3 is equal to 4x plus 6. 4x plus 6, and then we will make it simple. So 4x minus 6y, and this is plus 6, This is 3, goes there, so plus 3 is equal to 0. Wait, I got it wrong again? Oh, holy moly. I got it wrong. So we made a mistake here. Instead of minus, it was positive, so it's minus. That means this is minus, that's minus 6, and then this is the equation I will get in the end. So it's 6y plus 3 is equal to 4x minus 6. We maintain the 4x at the side, we brought 6y to that end, and then we brought 3 to the other end, and then we should flip the whole equation. Right, so you try that, and then you try other equations too. You try other equations too, other questions too. In example 3, we've been given 2 equations. Alright, I've not written with maybe blue. So in equation 2, we've been given 2 equations. And then these equations will help you find m, because they said in the question that they intersect at m. So you've solved them simultaneously to find m. Now in the B part, the line passes through m. That means that's a point to find the equation of the line, right? Find the equation of the line. So we are finding the equation of another line. A line that passes through m, right? We are finding the equation of another line. A line that passes through m, and then we know how to find m. And then it's parallel to the line this. If we can find the gradient of this line, which is m, the gradient of this line is the same as the gradient of the line we are about to find. Why? Because they are parallel. When lines are parallel, they have the same gradient. It means here, we won't use m1, m2 is equal to -1. We use this for perpendicular lines. Here they are parallel, so m1 is equal to m2. This is what we use for parallel lines. So you can solve it, and then you can try some other examples here. 4, 5, 6, and then yeah, that's all for perpendicular and parallel lines.